Thermal Power Corporation presents the exclusive Thermal Power Thermal Crack Eliminator. The Gratiot County Airport in Michigan is one of the many general aviation airports that have the job of maintaining thermal cracking that appears in all asphalt runways and taxiways. These thermal cracks appear in all airports with asphalt runways and taxiways, no matter what the size or how thick the asphalt. We have completely removed thermal cracks as wide as 5 inches. The thermal power method does not maintain thermal cracks, it eliminates them. The thermal cracks at this airport average about 2 inches wide. The asphalt was approximately 6 inches thick. In addition to the crack, the asphalt surface has dips starting approximately 1 foot on each side of the crack. The patch master heats the asphalt beyond 1 foot of each side of the crack while heating into the crack. The patch master's radiant heater heats each side of the crack's walls the full depth of the crack. Then, the heated asphalt is raked into the crack and mechanically driven down into the crack. A special tamping tool drives the hot asphalt down into the bottom of the asphalt crack, and the heated asphalt melts into the heated sides of the crack, creating a homogeneous bond. This procedure takes place a number of times, depending on the thickness of the asphalt. On this 6-inch thick asphalt runway, the procedure was repeated 3 times. Then, while the scarified asphalt extending 1 foot on each side of the crack is still hot, additional asphalt is added to fill in the dipped sections of the asphalt pavement, making a smooth, homogeneous repair. All thermal cracks, whether vertical or horizontal to the runway's edge, are rapidly eliminated, and the runway can be opened up for air traffic immediately. Keep in mind, at any time during the repair process, the runway can be opened immediately, and in the event of an emergency, the entire crew can be clear of the runway in less than 10 minutes. We compared the thermal bond method of eliminating the crack to the temporary felt rope and rubber crack filler. Please notice where most of the rubber has fallen down into the crack. In the winter, the crack expands wider than the rubber can stretch, loosening the rubber and the felt from the edge of the crack, allowing it to fall down into the bottom of the crack, making repeated repairs necessary. Unfortunately, the aircraft and the passengers have to put up with the thump, 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 thump all the way to the terminal. We took a core sample from a thermal crack elimination area. As one can see, the thermal crack has completely disappeared, leaving a completely homogeneous piece of asphalt. It is as solid as any other part of the runway. Now we are going to take a core sample where the thermal crack was filled with a felt rope and hot rubber. As one can see, the felt is about 1 inch below the top of the asphalt. Rubber is poured into the crack from the felt rope up to the top of the pavement. The rest of the crack is left for the water to rest and freeze, which will push the crack wider than the rubber is designed to stretch. Here we have a direct comparison of the 2 core samples. The thermal power core repair sample is solid with no indication that a crack ever existed, unlike the felt rope and rubber repair core sample. There really is no comparison. To quote an FAA representative that was present, he said, if someone would have sent him a thermal power, thermal bond crack repair core sample to his office, and he hadn't personally witnessed the repair like he did, he would not have believed that it could have been done, and the core sample would have gone in the trash. Now, you've seen it too. For more information, visit us on the web at www.smoothroads.com or give us a call at 1-800-677-9422.